Hello viewers, welcome back to another session with me. This is a mind-blowing session. Please stay tuned. You are welcome to Master Builders Online Academy. If you are new in this channel, do consider subscribing to our channel and ensure you turn on the post notification bell for more exciting videos. Yes, more educative videos. Now guys, I stand to remind you our policy. Anytime you are set to watch and to learn new concepts from our platform, do not skip any part of the video so that you will not skip a vital aspect of the video that will have made you gain mastery over the lesson. And also, anytime you are set to watch and to learn new concepts from Master Builders Online Academy, do not welcome any form of distraction. Pay close attention so that you will be able to gain wisdom. And finally, if you watch this video for the first time and you do not understand some mysteries, guys, you have the opportunity to replay the video over and over and over again until you understand it. And if at the end of replaying the video countless times and you have questions to ask, guys, do not hesitate. All you need to do is to slide to the comment section and make your questions known to us. We will attend to your questions and give you befitting answers. And now don't forget also to like this video, share this video, and appreciate us at the end of gaining values on this platform. Now guys, on the board we have problems and solutions. In our previous lesson, we actually looked at a case where we were deriving models in fluid methods, deriving formulas. But in this lesson, we are going to be looking at problems and solutions using those formulas we have obtained to calculate for the respective unknowns. Now, on the board, we have problem number 1. We have that a diver descends from the surface of the sea to a depth of 30 meters. Full stop. What will be the pressure under which the diver will be walking above the surface, assuming that the intensity of the sea water is 1035 kilograms per meter cube and remains constant? This is one of the simplest questions you will ever see in this aspect of pressure measurement. So the first thing you will always do when you are dealing with word problems is that you need to state the given parameters, which include the unknown and the known parameters. So let's do that. Now we have given that from this question we are asked to find pressure. Don't forget, we are asked to calculate pressure. What will be the pressure? So pressure P is unknown. Now we have the depth from which the diver descended the sea. Then we have depth H, which is 30 meters. Then we were equally given the density of the sea, water. So density is given as 103 kilogram per meter cube. Then finally we know that acceleration due to gravity, which is D, is 9.81 meter per second squared. We are asked to find pressure. All we just need to do is to look out for a formula that connects these 4 parameters. And we quickly recall that pressure P is equal to rho GH. You remember when we derived this equation in model 2? This is it. I know density. Acceleration due to gravity is constant. Then I was given H. Impute your value, compute, you are done. That's all. Therefore, P would have given us 103635 multiplied by 9.81 multiplied by 30 meters. And the unit would have given us Newton meters squared. Now, 1035 multiplied by 9.81 multiplied by 30 is 304,600.5 Newton meters squared. So you can start to convert to kilo, mega Newton, as you wish. But let's convert this guy to kilo. This would have given us 304.6 kilonewton meter squared. This is the answer to this very question. It's just for you to understand, then interpret the question, extract the given parameters, which include the known and the unknowns. That's all. Once you do that, you will be able to access the formula that connects the known and the unknown parameters. Hope this is helpful. Don't forget to subscribe. Don't forget to share. Don't forget to like. Just give us a thumbs up. Now, we have problem 2 on the board. We are asked to find the head of oil corresponding to an intensity of 350,000 Newton meter square, comma, the density is this. It is very, very simple. Now, the first thing you need to do is to read the question carefully and extract the parameters, the given, which include the known and the unknown parameters. So now we have this as solution. Then given that, now with the unit of the value we have here, we are able to know that this is pressure. You see, from this question that we have here, pressure was not mentioned directly. There is no pressure here. A word such as pressure is not found here. But the unit of this value has already given us the sense that this value is pressure. That means pressure is given. Then we have pressure is equal to 35000 Newton meters. Then the next parameter that is given is the density of the fluid, which is oil. Then we have density of oil given to be 980 kilogram per meter cube. And we equally know that acceleration due to gravity, whether or not you are given, is constant. So 9.81 meter per second square. Now we are asked to find the head of the oil. Now listen carefully. In fluid mechanics, depth is the same thing as head. In other words, head is the same thing as depth. That is to say, in this question, we are asked to find the depth. Unlike the first question we saw, where we were already given the depth, but in this case now, depth is unknown, while pressure is known. All we just need to do is to what? Recall the formula again. Now we know that depth or head. We know that head, H is unknown. So recall that pressure is equal to rho GH. Now if I make H the subject of formula, I will divide both sides by rho G. Then this will have given me P all over rho G. H would have given us 350,000 Newton per meter square all over 980 kilogram per meter cube multiplied by 9.8 meter per second squared. And when we multiply out the denominator and then divide the numerator by the outcome, the answer becomes 36.4 meters. This is the head of the oil corresponding to that intensity, pressure amount. So guys, this is very, very simple. The next is for us to look at question number 3 and question number 4 very quickly. Now we have question number 4, 3 and 4 on the board. For question number 3, problem 3, what will be A? Roman figure 1, the gauge pressure. Roman figure 2, the absolute pressure of water at a depth of 12 meters below the free surface. Now, assume the density of water to be 1000 kilogram per meter cube and the atmospheric pressure as this. Whether you are given the density of water or not, remember always that the density of water is 1000 kilogram per meter cube or 1 gram per centimeter cube. Alright? all we need to do now is to extract the given parameters as usual. Now we have given that depth H is equal to 12 meters. Then density of water is equal to 1000 kilogram per meter cube. Then atmospheric pressure is equal to 101 kilo Newton per meter squared. Then we equally know that acceleration due to gravity is 9.81 meter per second squared. Now we are asked to find the gauge pressure. This is the gauge pressure. That's it. Now the first thing is question number A, gauge pressure. And the gauge pressure is the pressure with variation with depth. So we just have that P is equal to rho G H. Now we impute in the value of density, which is 1000, multiplied by 9.81, then multiplied by 12, now giving us the unit Newton meter squared. Now when we multiply 1000 by 9.81 and then multiply the outcome by 12, the final answer becomes 117,720 Newton meter squared. Convert this value to kilonewton meter squared. We will divide this by 1000, and when we divide this by 1000, we have 117.72 kilonewton meter squared. This is the gauge pressure. It's as simple as this. When you know principles, you become a principal. Extract the parameters, both known and unknown. The formula will unveil itself. Then next, B, we are asked to obtain absolute pressure. Absolute. Now understand that absolute pressure is equal to gauge pressure plus atmospheric pressure. This is what your absolute pressure is all about. And we know that the gauge pressure is rho G H plus atmospheric pressure. Now I have already obtained the value of rho G H, which is this, and I'm given atmospheric pressure. So the gauge pressure would have become the sum of this guy and the atmospheric pressure given. Then we have 117.72 plus, don't forget the unit is already in kilonewton per meter squared. While this guy is equally in kilonewton per meter squared, so we can add them up. 101 kilonewton per meter squared. Now, when we add 101 to this guy, this will have given us 208.72 kilonewton per meter squared. This is the absolute pressure for this particular question. Very simple. So understand that gauge pressure is the pressure with variation with depth, which we have this. While absolute pressure is the sum of gauge pressure and the atmospheric pressure. If this is taken, let's look at the problem number 4. Don't forget, when you know principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. Now, at what depth, problem 4, below the free surface of oil, having a density of 600 kg per meter cube, will the pressure be equal to 1 bar? There is nothing to be scared of. It's the same problem. All we need to do is to extract the given parameters. Now from here we have given that density of oil 600 kg per meter cube. Now pressure is equal to 1 bar. And we know that 1 bar is equivalent to 100,000 Newton/meter squared. So don't forget that one pressure is equivalent to what? 100,000 Newton per meter squared, or 10 raised to the power of 5. We have this as 10 raised to the power of 5 Newton meter squared. Like I said, this is 100,000 Newton per meter squared. That is what we have one bar to be equivalent to. Then we have depth h as unknown, and we equally know that acceleration due to gravity is given as 9.81 meter per second squared, standard. So now all we just need to do is to recall that gauge pressure is equal to rho GH. Now we know P, we know density, we know acceleration due to gravity, we are looking for H. We simply make H the subject of formula, which is the head. Then we have H is equal to P over rho G. And this is equivalent to 10 raised to the power of 5, which I said is 100,000, all over density is 600 multiplied by 9.81. And when we divide 100,000 by 600 multiplied by 9.81, the final answer to this question would have given us 17.0 meters. This is the head of the oil below the free surface of the water. So guys, you look at these questions, you find out that from question 1, 2, 3 to 4, all the problems are the same. All you just need to do is to understand principles. When you understand principles, you become a principal. So if at this point you are yet to subscribe, please consider subscribing to our channel, and ensure you turn on the post notification bell for more educative content. So guys, see you in question number 5. Hello viewers, welcome back to class. Now in this lesson, we shall be looking at question number 5. So if you are new in this channel, do consider subscribing to the channel, and ensure you turn on the post notification for more exciting videos. Like this video, share this video, and make your necessary comments at the end of watching this video. Now on the board we have problem number 5. The figure below shows a fluid A, which is water, and fluid B is oil of relative density this. If H is 69 cm and Z is 23 cm, what is the pressure difference or difference in pressure in kilonewton per meter squared between point M and N? This is M, this is point N. This is very, very simple. To be able to solve problems on manometer very well, U-Tube Manometers, you actually make use of Pascal law of pressure, which was the first proving that we did in this lesson. That was the first proving that we attended to. Now, if you look at this figure we are given, you will find out that some portions are shaded, while the other are not shaded. Now, when you look at the portion that is shaded, you see that it's labeled as fluid A, while the unshaded portion is labeled as fluid B. Are we there? That is to say, this end and this end, they are made of the same property, while this other end is made of another property. Now, all we need to do is to get a level from this end. We can call this level SS, which will have become our datum or point of reference. The analysis will start from this reference line. Now, in using Pascal law, the pressure acting at this left limb is equal to the one acting at the right limb. But first of all, we need to know the depth of the various liquids that we have here. The various fluid now, from this end to this end is H, and is already given. From this end to this center is not known. So we can simply say, let's take from here to this end as to the center here as D, or any letter different from the ones we already have here. Now we were told that from this center to this point, the distance that we have is Z. So therefore, from here to this point, we equally don't know it, but we know from here to this end. From here to this end is Z. But from this point to this point, which is the center of this guy, we do not know this. Then we can equally represent this with another letter. Let's call this small letter A. We want to deduce a mathematical model from this question. And how do we go about this? First is to understand that from this end to this end is H plus A. And also, we need to know that from this end to this end would have been H plus A plus Z. And we're told that H is equal to 69, while Z is equal to 23. Now, we equally know that it is impossible for us to solve with centimeter. Now that the question states that we should leave our answer in meter square, that is to say, we will convert these values to meter. Then, if this is solution, we have given that Z is equal to 23 cm, which is the same thing as 0.23 meter. To convert from cm to meter, you divide the given value by 100. Similarly, H would have given us 69 cm, and this is equal to 0.69 in meters if we divide by 100. Now we know that we have two materials here, which is water and fluid B, which is oil. So for water has a standard density of 1,000 kilogram per meter cube. That equally use this as 10 raised to the power 3 kilogram per meter cube. While the density of oil is equal to what? The relative density of oil multiplied by the density of water. And the relative density of the oil given is 0.9 multiplied by the density of water. And when we multiply out this will have given us 900 kilogram per meter cube. Now we have the density of the water. We now have the density of oil. That is it next. Now the next is from here to this end, I already know the depth of the oil. Now from this end to this end, I do not know the depth of the water. So I can decide to call this guy from here to this point as B. From here to this point would have been the depth of this water. From here to this point would have been the depth of this other water. Then how do I get D and B, including A? Now we understand that B is equal to H plus A using geometric relationship. So we have B is equal to H plus A. Are we there? Then as we move further, the value of D would have been A plus Z, because we said that from here to here is A and from here to this center is Z. That means D is equal to A plus Z. This is it. Now all we just need to do here is to now substitute into the equation. Now I know the relationship between these guys. I now know the depth of D. I know the depth of water to this end. I can now make use of Pascal now. From Pascal, we have that the pressure acting at the left end of this M must be equal to the pressure at the other end, X on N. This is Pascal law. The pressure acting at the left end is equal to the pressure acting at the right end, in as much as this fluid is at rest. Now, what is the pressure at this end? What is the pressure at this end? Now, very quickly, the pressure at this end would have given us P, M, P at this V, which is PM. Now, we know that this is inverted U manometer. This is the actual symbol of U. So, when I have it this way, it's inverted. So, for U manometer, you take the pressure with depth as negative pressure. Therefore, this will have given us negative density. Now, what material is here? The material that is here is water. So the density of water multiplied by acceleration to gravity multiplied by the depth there, which is B. That is all that we have to be left. Now, equal to, so at the right end, we have the pressure acting at this center here, at this point. And that pressure is Pn. Now, all other pressures will be negative because this is an inverted U manometer. Therefore, I will come to this end. From here to this end is a material called fluid B, which is oil. So I will use the density of oil, multiplied by acceleration due to gravity, then multiplied by the depth of the oil, which is H. And at this end also, I have another fluid, water. And the depth of this water is D. And now the density of water is rho W G multiplied by what? D. That is the depth of water at this end. We have three depths, B, H, and D. And that's what we already have it. Now the next thing we are quickly going to do is to make Pn and this guy the subject of formula. So when I take this guy to this end, it becomes minus Pn. And when I take this guy to this end, I have rho of water, Gb. I'll take this guy, rho of water, Dg. Then minus rho of oil, Gh. This is it. Then at this point, all I need to do is, now the density of water multiplied by acceleration due to gravity is common between these first two terms. Therefore, I will quickly factorize. I have this guy as this. Minus Pn is equal to density of water G multiplied by B minus D. Then minus density of oil, acceleration due to gravity. Now, what is B? What is D? We know that B is equal to H plus A and D is equal to what? A minus Z. Then we have this as Pn minus Pn is equal to density of water, G, open bracket. The value of B is H plus A, close bracket. Then minus the value of D is A plus Z. Then close the bracket. Then minus rho of oil, density of oil multiplied by acceleration due to gravity multiplied by the depth, which is H. Now, we have rho of density of water multiplied by H. When we remove the bracket, this becomes H plus A minus Z minus rho of water GH. And this will have given us this guy. A takes care of A. We have H minus Z minus rho density of this guy multiplied by the depth. So at this point, we have H known. We have Z known. All we just need to do is to substitute for H and Z. We are done with this question. So at this point, we put in the density of water, which is 10 to the power of 3, multiplied by 9.81, multiplied by H is 0.69. Then minus the value of Z is 0.23. Then minus the density of oil is 900, multiplied by acceleration due to gravity 9.81, multiplied by 0.69, which is the height of the oil. Now when we multiply out this, we simplify this term, this will give us 4512.6, while this will give us 609,201. And when we remove this guy, we have negative 1579.4 Newton meter squared. This is what we have. When we simplify this, we have this. When we multiply this guy by this guy by this guy, we have this. Now when we remove this guy from this, this is what we have. Now the answer said that we should leave our unit in kilonewton per meter squared. And when we convert this to kilonewton per meter squared, we will simply divide this value by 1000. And when we do that, the final answer becomes negative 1.5794 kilonewton per meter squared. This is the answer to this very question. Like I said earlier, it is very, very simple to handle. The next is to look at question number 6 very, very quickly. Now, don't forget, when you know principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. At this point, if you are yet to subscribe to this channel, do consider subscribing to the channel and ensure you turn on the post notification bell for more educative content. Now guys, welcome back to this session. We have question number problem 6 on the board. An inverted U-Tube shown below is used to measure pressure difference between 2 points A and B in an inclined pipeline through which water is flowing. In this manometer, water is flowing through the pipeline. The difference of level H is given as 0.3, A is given as 0.25, and B is given as 0.15 meters. Now we are asked to calculate the pressure difference, PA minus PB, if the top of the manometer is filled with 1, air, number 2, oil of relative density 0.8. This is the question. Now, this is what we are given as the figure. Now, from this end, we see that this end is shaded and this other end of the manometer is equally shaded. But this top end is not shaded. Now, the end that is shaded is the water, while this top end is what can likely be the air or the oil as we have in these two cases. So first is to understand that now that I have two materials here or two fluids here, I need to know their respective depths. So guys, let's look at that. Now let's quickly take a datum, which is x. Alright? Now from here to this end is H, and that contains either air or oil. Now from here to this end is water, and the depth is already known to be what? Is already known to be A. Now, but from here to this end is all water. But we do not know the depth from here to this point. But we know from here to this point is B. But when you look at the relationship between these signs, you will find out that from here to here is A, equally from here to this end is A. That means the depth of water at this end would have been B plus H. So I can equally say that from here to this end now is B plus H. So this is the depth of water at the right end. Now the next thing we are quickly going to do is we will quickly apply the Pascal law of pressure on this manometer. And how do we use that? We said that the pressure at this end, which is A, must be equal to the pressure at the end, the other end, B. This is Pascal law of pressure. Now the question is, what is the pressure to the left end? And what is the pressure to the right end B? The pressure to the left end would have been pressure at point A. Being that this U-Tube manometer is inverted, all the pressure with respect to depth will be negative. Are you there? So therefore, from here to this end is a material. I will have rho of any material. Let's assume we put this without symbol. Okay, let's take this without any subscript symbol. Then the density multiplied by acceleration due to gravity multiplied by the height. We are done with obtaining the pressure for this guy, which is called the gauge pressure. Now for this other guy, from here to this end is water, and that the density of water will represent it with what? Rho subscript W multiplied by acceleration due to gravity multiplied by the depth of that what? Water. And the depth of water here is A. Then we are done with the left end. Now at the right end of the tube, we have pressure at this point B minus the pressure A. And the pressure here is of water R2. Then I have density of water multiplied by acceleration due to gravity multiplied by the depth. And the depth here we said is B plus H. We now have B plus H. This is it. Then the next thing we quickly do is to deduce PA minus PB from here. Then we will collect like things. I have PA minus PB. That is to say, this guy and this guy, we will take them to the right end. And when we move this guy, this will have given us rho of GH minus. Now, anytime this guy crosses, it becomes plus, and when this other guy equally crosses, it equally becomes positive. Water G A, then minus rho of water G into B plus H. Now we find out that these last two terms have something in common, which is the density of water and acceleration due to gravity. Then we can factorize this guy out. We have that P A minus PB is equal to rho G H plus rho of water G. Now, when we factorize out this guy, we have A minus B minus H. This is what we have. So this becomes our model. Now, the first question is, when the top end, which is this density, is water, is air, what happens? We know that the density of air is 0, so we'll take this end A. Top filled with air. So when the top is filled with air, we know that the density of air is equal to 0. Automatically, this equation becomes PA minus PB would have been equal to, if I put in 0 here, 0 multiplied by everything here would have become 0. Then I have this guy as rho WG into A minus B minus H. Because the density of air is 0, automatically everything here will be 0 for air. Now this is all we just need to do now is to put in the density of water, put in acceleration due to gravity, and value of A, B, C, and H. Now we understand that the density of water is equal to 1000 kilogram per meter cube, and the acceleration due to gravity, is 9.81 meter per second squared. So we therefore have PA minus PB is equal to 1000 multiplied by 9.81, open bracket. The value of A, we'll come back to this point. The value of A was given to be 0.25, have 0.25, minus the value of B is 0.15, minus the value of H is 0.3. Then when we simplify this have given us 9810 multiplied by, then when we 0.25 minus 0.15 minus 0.3 would have given us negative 0.2. And when we multiply out this will give us negative 1962 Newton meter squared. Then we can simplify this, divide both sides. Now to convert this to kilonewton, we simply divide by 1000. Then this will give us negative 1.962 kilonewton per meter squared. Now this is the pressure in this U-Tube manometer when the top of the manometer is filled with air. Now, what is the value when it is filled with oil? So we can call this the top filled with oil. Now, what is the density of oil? We know that oil has a relative density of 0.8 as given in this question. And what do we do to this guy? To convert the relative density of oil to the density of oil, we simply multiply this 0.8 by 1000, which is the density of water. And 0.8 multiplied by 1000 would have given us 800. Therefore, we have this as 800 kilogram per meter cube. This is the density of the oil. Now, this general equation would have become PA minus PB is equal to the density of oil G H plus the density of water D into A minus B minus H. Now, guys, we can now substitute for density of oil and acceleration due to gravity. Now, the density of oil is 800 times 9.81 multiply by what? H, 0.3. Then plus that of water. And we know that from question number 1 or A, what we obtained was actually the pressure of water only. And we understand that everything here is the same thing as what we have already calculated before. That means I can replace this guy here without imputing the value of density of water as a relation to the gravity and the values of A, B, and H. I can just put in the value I already have here. You can work it out in your own case. But because of the space that I have here will not be enough, I will just put in the value since I've already calculated for it. Then this becomes 1962. Alright? Now when I multiply out this, I have 2354.4 minus 1962. And when we remove this guy from this guy, our final answer 392 Newton meter squared. This is what we have. Now if we convert this to kilonewton, this will have given us 0.392 kilonewton per meter squared. This is the answer to this very question. So guys, you see that this thing is very, very easy. All you just need to understand is application of principles and boundary conditions. And know that when you know principles, you become principal. And when you understand boundary conditions, you will not overstep your boundaries. If at this point you are yet to subscribe to this YouTube channel, please subscribe to our channel. Encourage us, it matters to us. Now guys, let's look at the next question. Now guys, welcome. We have question number 7 on the board. Don't forget this is a continuation class. Okay. Now we have a vertical pipe ejects water upwards to a maximum height of this 20 meters. Find the velocity of the spray at the nozzle and at a height of 15 meters from the nozzle. Very simple. That is to say the highest height that this water was ejected is 20 meters. So every other, we have them below 20 meters. So now if at a height of 20 meters, we have a particular reading, what would equally be the reading at a height of 50 meters? The first thing you need to know in this question is that anytime you are talking about nozzle in fluids, pressure is the same across the entire nozzle system. Are you there? So it shows that if we have this as given, that maximum height, let's use capital letter for maximum height is 20 meters. Then the other height, we use small letter, that is 15 meters. Now for nozzle, understand that pressure at the entry is equal to the pressure at the exit. So P1 is equal to P2 and both is equal to P. All you need to do now is to apply the Bernoulli's equation. Now we apply Bernoulli's equation. We recall that P1 over rho G plus V1 squared over 2G plus Z1 is equal to P2 over rho G plus V2 squared over this guy 2G plus Z2. Now the next we are quickly going to do is we have already taken note of the fact that this system is a nozzle. So for nozzle, P1 is equal to P2. And if P1 is equal to P2, that is to say, this guy will cancel out this guy. If we collect like terms, P over rho G minus P over rho G would have been 0. So we ignore. Then this would have given us V1 squared over 2G plus Z1 is equal to V2 squared over 2G plus Z2. Now, we want to work on at maximum height. Now, listen carefully. The first height we are given is 20 meters. Now, at maximum height at A, final velocity is 0. Now, it was projected from a point which we are called V1, initial point. Now, the other point is the final point. Understand that anytime you throw up an object vertically upward, final velocity is equal to 0. If I will remind you of the course projectile, you remember that topic, projectile. So anytime an object obtains a maximum height, the velocity at that point will always be 0. Therefore, at maximum height, V2 is equal to 0 because V2 is our maximum velocity. Automatically, this equation becomes 2g plus z1 is equal to 0 over 2g plus z. So from here we have v1 squared all over 2g is equal to z2 minus z1. And we know that the difference between elevation at the starting point and at the exit point is equivalent to h. Therefore, we have this as h. So we are replacing this guy with h. What do? We simply cross multiply and make v1 the subject of formula. We have v1 is equal to 2 rho h. And now this is v squared, so we quickly find the square root of both sides. This is what we have. Now, what is v1, which is the initial velocity? This would have given us rho 2 multiplied by 9.81 acceleration due to gravity, then multiplied by 20. v1 is equal to 19.81 meter per second squared. This is what we have. Then the next thing we are quickly going to do is to what? Consider the second case where we have a height of 15 meters. It is that velocity between the starting point and the ending point that we are looking for. So between the starting point and the ending point, there exists a velocity. It's only at the maximum height that velocity is 0. So what is the velocity at a height of 15 meters from the starting point? What do? We are equally going to apply the Bernoulli's equation. Now, at a height h equal to 15 meters, applying the Bernoulli's equation, we still have v1 over rho g plus v1 squared over 2g plus z1 is equal to p2 over rho g plus v2 squared all over 2g plus z2. So we are still dealing with the same system, nozzle system. And for nozzle, pressure at the entry is always equal to pressure at the exit. So the entry pressure and the exit pressure is the same. That means pressure is constant for a nozzle. So if pressure is constant, that is to say this guy will take care of this guy. But we equally have v1 squared over 2g plus z1 is equal to v2 squared over 2g plus z2. Now we are quickly going to make v2 the subject of formula. And now we have this guy as v1 squared 2g minus, when we take this guy, this gives us this all over 2g is equal to z2 minus z1. And we know earlier on that z2 minus z1, which is the difference in elevation, would have given us h. And in this case now, the h that we have here is small letter h. So this is actually equivalent to h. Everything here will represent it by h. Are we there? Now the next is the denominator between these two guys is the same. That is to say, I can have v1 squared minus v2 squared all over 2g. This is equivalent to h. And trying to make this guy the square of formula, but we cross multiply. And when we cross multiply, we have v1 squared minus v2 squared is equal to 2G multiplied by H. And finally, this guy would have given us V2 squared is equal to V1 squared minus 2GH. Just for you to take V2 squared to the right end and take this guy to this end. Make V2 the subject of formula. And when we do that, this is the resulting outcome. All we need to do now is to find V2. Becomes the square root of V1 squared minus 2GH. Now let's put in the values. We will get our final answer. What is V1? Now guys, V1 has been obtained to be 19.81. So we put in 19.81. Then minus 2 multiplied by 9.81 multiplied by 15. Now when we find 19.81 squared minus 2 multiplied by 9.81 multiplied by 15 and find the square root of the result, our answer becomes 9.91 meter per second. This is the answer to this question. So the velocity at a height of 15 meters is 9.81. Definitely it will be so, because if the initial velocity is 19.8, as the object gains height above the ground level, the velocity reduces. In other words, as the object approaches the maximum height, there is always a reduction in the velocity. And it is because of the reduction in velocity that actually brings the body to rest. So a body comes to rest when it is projected with a certain velocity, as the velocity reduces with respect to what increase in height above the ground level. Are you there? So if the value you obtain as V2 is greater than V1, you are wrong. This is the essence. Because we know that anytime we project an object from the ground level to gain a height, as it moves from the ground level to that particular height, the velocity reduces because of the effect of the gravitational pull on such bodies. So if this is understood, guys, don't forget to subscribe to this channel and ensure you turn on the post notification bell for more educative videos. So guys, we have successfully ended the part 2 of these lessons in fluid mechanics for year 2 students. Now guys, very quickly we will slide to the next session, which is the part 3 of this session, where we'll be calculating with the rate of flow. Guys, like this video, share this video, and make your necessary comments. Don't forget to give us the thumbs up. Now guys, if this is taken, don't forget that when you know principles, you become a principal. And when you know boundary conditions, you will not overstep your boundaries. So see you guys in the next class.